Hello, everyone. My name is Taras. I'm a software engineer at GlobalLogic. In this coding session, I'm going to show you how to solve coding task called maximum sum of two non-overlapping subarrays. Not just how to solve it, but how to approach solving algorithmic tasks, decompose them into smaller and much simpler subtasks that are easier to work with. Prerequisites. For this coding session, I'm going to use C# and .NET 8, although it's not very important for these simple algorithmic tasks because code in Java or JavaScript would be, or something else would be fairly similar, but I'm going to use C# and .NET. So prerequisites are basic knowledge of C# programming language, syntax, understanding simple concepts like classes, methods, conditions, cycles, etc. Also, you need to have working dev environment. This can be Visual Studio Code, or in fact, you can even use a C# fiddle somewhere online in a browser. I'm going to use Visual Studio Code here. And basically, you need to have a Hello World console application as a starter. So why this task? You can see the task on the screen, and it's taken from a LeetCode. It's available in internet. You can Google it. This is rated as a medium difficulty, and a lot of people, sometimes even experienced developers, do struggle with these kind of tasks. Because it includes some operations with arrays, lots of additional nuances, and requires some logical thinking and understanding how to program this all together. So I'd like to show you that if done right, this can be actually fairly simple, even for beginners. So please read this task, make a pause maybe, and assuming you read it, it's important to understand what it is required from you. So the way I understand this task in my own simple words. So we are given an array of numbers, and we need to pick a combination of two subarrays of given length in such a way that their numbers add up to the maximum possible sum. And then there are some additional terms like subarray ordering doesn't matter. So we're talking about two subarrays, first and second, but in reality, second can be first and first can be second, whatever. And also that these subarrays must not overlap, but we'll get back to that. We can also see it in an example here. So example number one, we can see the input numbers that we are given and two lengths. And the correct answer here will be 20. And the reason for that is because we select 9 as our subarray of length 1 and 6 and 5 as a subarray of length 2. And 9 plus 6 plus 5 equals 20. So we sum up and output 20. And intuitively, if we look into this inputs, we can actually see that this is right, because 6, 5, and 9 are the biggest numbers here. And it conveniently happens to be that 6 and 5 are next to each other, so we can combine them into one first, or to be more exact, second subarray. And then the biggest number 9 can be taken as a subarray of length 1. So we select 9 and 6 and 5, and we add it up to 20 together. So in this simple example, we can actually intuitively, even visually, identify that this is the right answer. But again, these inputs, they can be much more complicated, and it's not necessarily will be that simple. But anyway, I think we understand now our task, and we can start actually doing something. So we figured it on a first example, and numbers from a second example I'm going to take as a developer's data. So here is my Hello World application as a starter, as I mentioned, and we can even try to run it and make sure I have my development environment ready. So I have this Hello World output in a console, so I'm good to go. Okay, and let me just put my inputs. This is going to be our inputs as just a developer or testing data. And we can start by doing actually the method that is going to be our task entry. So this is going to be something like get to subarrays max sum. For now, it's going to return nothing, but we'll modify it in the future. And of course, it's going to have inputs. And I think I'd like to identify these input numbers explicitly that this is input. So I'm going to name them input numbers. And also, I would And also, I'm naming a bit longer and more clear these length variables. I think it's worth it. Okay, and we can make a call even here. Like that. Okay, so we prepared our task entry. And so now we need to think how we're going to approach this task. So we're given an array of numbers, and these numbers go in random order. So we cannot use some clever formula how to calculate which subarrays are going to have maximum sum. And this can be not clear at all. And because of that, we are going to use brute force to take all possible combinations of two subarrays, calculate them all of them their sum, and then compare them and just figure which combination of two subarrays provides us with happens to provide us with the biggest possible sum, and we are going to output it. So we are going to use brute force because again, there is no any correlation or sorting in this array or something. So what we want to do then, we want to select as a first step in solving this problem, we are going to select all possible combinations of two subarrays of input length. And I think even like as a very first step, I think we can even forget about a second subarray for a while and just select all possible combinations of one subarray, and then we'll add another one later. So how are we going to do that? So we're going obviously go from the start of the array all the way to the end and select every single index as a starting point of our candidate subarray. And you can see that this is a clear for cycle. So we already sort of understand what we want to do. And let's do it. So for our first step, what we are doing is we are selecting all possible candidates for our first subarray. So this is our first milestone. And as we already figured, this is a pretty clear cycle. I'm going to use for cycle. And usually it goes like this. We select some counter I less than input numbers length. I goes up. But in this particular scenario, I would like not to be lazy, and I would like to clearly identify what this I actually means. So what we are enumerating here, we are enumerating indices of our input array, and these indices are going to be our starter for our subarray. So I'd like to call it that way. So I'd like to call it first sub array start index. instead of I, it's a bit longer, and usually well-experienced developers just leave it at I. But for this coding session, I'm going to use long explicit names so we clearly understand what this I actually means. So this is a first subarray start index. And in fact, yeah, we did it. We pretty much did. We selected all possible starters for our first subarray. And what we want to do next is we want to do the same, but for second subarray. But we do not just want to select all possible starters for second subarray. We want to select all possible starters for second subarray for each candidate of a first subarray. So we are going to do cycle inside the cycle because we are enumerating all possible combinations. So this is obvious, another for cycle. Let's do it. And this time we are going through second. So I'm also calling it second. So this way we are going to select all possible starting points for our first subarray, and then for each of that we are going to select all possible combinations for of second subarray. So inside this brackets, we're going to have all possible combinations of two subarrays, and that is in fact it. So our first milestone, what we wanted to do, we wanted to select all possible combinations. It's pretty much done here. I really usually hate to write a lot of code and then try to run it in the end and hope for the best. So instead, I'd like to now, even when we did some small bit of coding, I'd like to actually do an output, and I want to check what we've got here. So I'd like to now, what I like to do is I like to print our subarray combinations, first and second subarray, to the console. So I'm going to pause a little bit solving my task and just do additional console printout, and I'm going to do it in a separate isolated method so that it's not messed up with the algorithm and stuff. So I'm going to create another method called static void. Let's say print subarray combination, or I will use pair because pair is a shorter word. And what I'm going to do here, I'm going to write console write line subarray pair. So this is going to be my header. Then I think I want to also somehow isolate, because I'm going to put out a lot of these subarray pairs. So I just want to clearly identify where is the beginning and where is the end. So I'm going to use this line as an ending. And now I want to actually print my subarrays. So I already have subarrays, and let's manage inputs. So I'm going to use input numbers as a source for my subarray. Then I obviously need first subarray index where the starting point of my subarray. I need also length here for this subarray. And then the same thing, except it's now for second subarray. So we have these inputs, the source input array, and then we have start index and length for both of our subarrays, and that's enough to print out our data combination of these subarrays. So again, when we are printing out subarray, this is obvious another for cycle. So let's do it. For and the starting point for this for cycle is going to be start index of a subarray, obviously. Then we are going to iterate all the way up to the last number of this subarray, and we do not have the last number, but we have start index and we have length. So we can actually calculate it. It's going to be starting index plus length. And then we're going to increase the counter, and I'm going to leave an I here because it's a simple for cycle, and I think it's pretty clear what we are enumerating through. And what we want to do here inside this cycle is we are going to write every single subarray number, which is going to be maybe like that. So I'm going to put out input numbers of index I, and then I want to add space so I can separate each number of array from another one. And also, after cycle is done, I just want to add a line break like that. And then we need to do the same except for the second subarray this time. So let's do it. And now it's a second subarray start index, second subarray plus second subarray length, something like that. Oh, right line, I think, here. And also I will add line break here too. So we put out our, so we developed this method for printing to console our subarray pair. And now I think I can, within the cycle, when we have all the necessary information, start index for first, second subarray, the length and input numbers, we can actually do the call here. So we're going to parameterize it too. So first is start index, then first subarray length, second subarray start index, and second subarray length, something like that. Okay, but I think that experienced developer will immediately see the issue with this code here that I have. It's not going to work, but in fact, let's even try. Let me run this code and see for ourselves what's going on. So we can see that something was put out to console here, but we have this problem, which is out of range exception. And experienced developer will immediately know why, because in fact, let me stop this, because what's going on here? So when we are going in this for cycle, we are enumerating through our input array, and we are going from 0, from the very, very first item in this array, all the way up to the last number, so up to this one. And this last number can be starting index for subarray only in case if this subarray has length 1. Because if it has length more than 1, obviously here, when we are trying to print it out, we are starting to refer to numbers somewhere beyond our number range, and hence we're getting an exception. So we now need to fix that. So we already prepared combinations, but this code does not quite work because we still need to manage our ranging. So we need to figure out that and throw away pairs which run out of range. So how are we going to do that? We can in fact modify this for cycles, but for simplicity and for clarity of code, I would like to make this work isolated. So this is going to be our next step, to fix our subarray pairs that we selected and to make them actually correct, because now they are not quite. And this is our next step, next small milestone, and I'm going to do it as an isolated step in a separate method. So I'm going to create a new method called static void validate, let's say validate subarray pair. And I think that inputs for this is going to be exactly the same as for printing to console because we are working with the same data. And now I need to validate this out of range thing. So how I'm going to do that? I think that we need to make some condition. We need to do some checking, like if condition. And we need to make sure that our input numbers length is bigger than our last end index of a subarray. And let's write it down. Let's say first subarray and index. But we do not have this end index, in fact. But we can calculate it. So we can now introduce this first subarray end index, and how it's going to be calculated. So we are taking first subarray start index plus first subarray length, and additionally -1. So why -1? This is exactly the reason why, for example, here in the 4 cycles, we are going all the way to length, but we are not including length. So we are going less than length. We are not going less than and equal than length. So in a zero-based indexing, as we have in a C# and .NET, the last index is going to be length -1. So hence -1. If it's not obvious, you can put a breakpoint and try without -1 and see why we need this -1. And okay, so we have a first subarray end index, and we can actually in the same way do the second subarray end index. Let's do it right away. It's going to be second subarray start index plus second subarray length. And now when we have our end indexes, we can just check them against length. And maybe this time I would like to do it in a negative way. So I'm going to filter out negative scenarios. If this subarray index is bigger or equal than a length, this is wrong. This means that we are going out of range. And in this case, I'm going to return false. And obviously, we need to put a return type as a Boolean. So this validate is going to return a true if subarray pair is valid and false if it's not. And we already checked first subarray for out of range. And now let's do the same, but for second subarray. Something like that. And by default, I think we can return true, because if these conditions were not triggered, then in this case, I think we're good. And we can actually now do the validation. So we right now inside this 4 cycle, we are doing validation, putting the same parameters here. And we are going to check if validation goes, or rather is not going through. So I'm checking if subarray pair is actually invalid. And if it is invalid, I'm going to just quit here. So I'm going to do a continue operator, which is going to just break out of the cycle. So if subarray pair is not valid, we are just going to skip right to the next loop of this 4 cycle, and we are not going to make here. So in fact, if we make here, it means that here pairs are correct. And in fact, let's run the application and see how it works now with a validation in place. So let me maybe just quickly clear my console and run it. And we can see that this time we have a good run, and we have no crashes, and we put out a bunch of subarray pairs and even hello world here. And we can see that we actually printed out all our subarray pairs. So we have a combination, and we know that this code works. Except we have now another problem. I think it's immediately apparent here that even the last output that we have, this last combination that was printed out was that first subarray of length 3 is going to be 890, and the second subarray of length 2 is going to be 9 and 0, and they overlap. And we remember that by our task description, they should not overlap. And this makes us, for our next third, I believe now, step, is that now we want to fix it to make these array pairs that we selected in this double for cycle. We want to make them non-overlapping, because this is what it is required from us from a task description. So how we're going to do that? I think I'm going to, so this is our step, next milestone, step 3, I believe. And I'm going to do this right in this validate subarray pair method. It already returns Boolean, and I'm just going to add some extra conditions here. It can be separate method, but let's use this one. And now we need to figure, we have all our information in place. So input arrays, starting indexes and lengths. So how we're going to figure whether they overlap or not. So in fact, this is pretty simple a task, but you can think about it. So we can have two situations here. We can have situation when first subarray comes first, and when second subarray also comes first. So these are two cases. And we first now want to figure which subarray comes first. And if some subarray comes first, it in fact must also end first. Because if it comes ahead of another one and ends ahead of another one, it means that they do not overlap. If it begins ahead of one, but ends after one or simultaneously or whatever, it means that we have an overlap. So now we want to actually do this checking. It's fairly simple. So yeah, let's do it. These are going to be another if condition, and what we want to first compare, we want to compare start indices. So let's compare a first subarray start index and the second subarray start index. Okay, so here, if this condition is going to work, it means that first comes first. Let me clarify first subarray. So the starting index is less than second subarray, it means that it comes first. And then if it comes first, we must also ensure that it ends first too. So let's do another if condition here. And let's now check end index. We have end index here. If end index also smaller than second subarray start index, we are returning true. So it means that there is no overlap. But in all other situations, we are returning false, because if it equals or bigger or whatever, it's false, it's an overlap. And then I think we figured this situation, and then we need to do the same situation, except we need to check the second subarray. So let's do it. So now we are comparing if second subarray is first. So this means that second subarray comes first. And we are doing additional check if second subarray end index is less than first subarray start index. Then we return true. In all other situations, we are returning false because that's an overlap. And I think these two conditions pretty much cover it, except maybe they do not cover the situation when indices are the same. So for all other situations, we're just returning false. We could make this code in a way so that we never make it to this return. But anyway, let's keep it. And for a situation when starting index is the same, it's going to return false. So we extended our validate subarray pair, and now this validate subarray pair checks for two things: for out of range, so we are throwing away all incorrect pairs because they go somewhere out of range, and we also throw away the situations when this subarray pair overlaps between each other. And so we added and pretty much completed this validation. And let's now, having this updated code, let's run it and see what's going on. Let me just clear it again and not run it. And so now take a look. So now we have input, pretty much the same input, except now we no longer have this subarray pairs that overlap. So the last output here is for a subarray of length 3, it's 890, and for another subarray of length 2, it's just 21. So it already disregarded all these other pairs that had some overlap, and we can review the output that this looks about right. Okay, so I think at this point here, when we are printing out our subarrays, we pretty much have our pairs. So we wanted to brute force compare all the pairs in the beginning and try to figure which sum is the biggest. And now we have these pairs. So now we can actually go to work with sum. So now what we want to do, and this is our fourth step or fourth milestone, is now to actually do the sum calculation. We want to calculate. We printed out the subarray pair, but now instead of printing the numbers that are in subarrays, we want to have the sum instead. So this is going to be a separate isolated method. I'm going to call it. It's going to return integer because we are going to calculate sum. I know it right away, and I'm going to call it get subarray sum. And unlike for this validate and print, I'm going to work with only one subarray, not with a whole pair. So I'm going to use only 3 parameters, which are going to be, maybe this is more a correct way of doing things. And I'm going, instead of first and second, I'm just going to call it subarray start index and subarray length, something like that. And now we want to calculate, I think it's clear for cycle. We want to go through all the numbers in this subarray and add them all together. So I'm going to create a variable sum. And then I'm going to make a for cycle. So I'm going from starting index. I'm going up to start index plus length in the same way as we did when we printed out to console and stuff. And I'm going incremental. And here I'm going to just add some. I'm going to accumulate everything that falls into this array like that. Yeah, I think that looks about right. Oh, okay. And we also need to return some. Here, where pairs are correct, we can actually do this subarray calculation. So let me do it here. I'm going to put input numbers there. Also, let's first do calculation for first subarray. Get some space. It's first subarray length. So this is going to be calculation for our first subarray, and then we want to do the same thing for second subarray. So let's do it. Second subarray start index, second subarray length. And we also wanted to add this one to another, and let's write it to a new variable, which is going to be called sub, well, let's call it just pair sum. Okay. And I think we no longer need this subarray pair console print. So I'm going to comment this out. And instead, I'm going to write new output here, console write line. And I think I'm going to just print out, instead of subarray pairs now, I'm going to print out only their sum. So let's do it like that. Good. So we added now calculating a sum of these subarray pairs that we selected in the previous steps. And let's run and see what we've got. And you can see that now, instead of subarray pairs, we get our output, we get our pair sum numbers. And look at what we have now. So basically, we have now all possible sums of all possible subarray combinations, and we want to pick the maximum one. So at this stage, our coding task reduced to just simple find maximum task, which is much simpler. And how we're going to do that? We are going to just create right here a new variable, which is going to be called max sum. And I think I'm going to make it nullable. So the reason why I'm going to make it nullable, unlike, for example, here where I calculated sum and I can put initial value as 0, because 0 has no impact on a sum. We are just accumulating here the numbers. Here I'm looking for a maximum, and I cannot use 0 as a default value, because it can be a situation when all numbers are negative. And for example, the biggest number is -10. And in this case, I will not be able to save -10 here if I have default 0. So I'm going to use nullable variable here. And let's return a nullable integer also here in this method. And now I just want to pick out of these numbers that I printed out to console. I just want to pick the biggest one, and that's it. So let's do it. So let's do additional, let me comment out console output. So let's do additional step, and I'm going to check if pair sum is bigger than the max sum. Then I want max sum to set as a pair sum. So if pair sum is bigger, we are saving a new maximum. And also I need to, for the first write, I also need to always save it. So if has no value, like that, or pair sum is bigger than the max sum, we are writing and remembering this max sum. And that's about it. And now all I need to do is I just want to return our max sum. And I think we already developed this method that actually does what our task requires us to do. And let's now save it to this variable result, let's say, and let's put it out to the console. So result. And let me run the application. And you can see that we have result 29. So we have 29 input here, output, sorry. And if we go to our example, we used these numbers as our developers' data. We have the output 29. And you can check it, but I'm pretty sure that example 3 is also going to work. And I think that's it. So I hope I showed that these tasks that might seem complicated at first, if done right and if split in correct steps, it can be simple. And at no point in time we were doing some complex calculations and other stuff. And we're writing some extremely hard conditions and etc. But we just split it in small steps, milestones, and all of them were isolated work, and all of them were simple. And we completed this medium difficulty task, and I think it's pretty friendly for beginners, even in this approach. But this task actually has more to give. Because this code that I developed, I think it's pretty good in as far as understanding the code goes, but it can be improved a lot. It can be improved in both in terms of efficiency and in terms of readability too. So let's first talk about readability. For example, here in these methods like validate pair, you can see that I'm putting out. I'm taking a lot of parameters. I'm taking 5 parameters, and by taking these parameters, I'm a bit pushing the limit here because that's a bit too much, and they all are of the same integer type, and it's quite easy to confuse them. So and you can see the common theme across this code is that we are using next to each other always this subarray characteristics, which is starting index and length. And I think if we see that there goes start index and length, start index and length, start index and length, we can maybe combine it into a new data type. So we can create some structure or class and make it a properties. And this way we're going to put here only one parameter instead of 2. And if we create this class, we will also be able, for example, to make this and index a calculated property of this class, so instead of calculated it in line when we're doing this algorithmic task. Also, maybe we would even be able to make this print subarray pair a method of this class. So just class that is called something like subarray has method to print itself to the console and stuff. So this is area for improvement as far as readability and understanding of code goes. You can try it, and this is probably how it would be done in a real-life commercial project. And another area for improvement is efficiency. So in fact, this code is not the most efficient, and this can be improved. And mostly the area for improvement is reducing the number of for cycles that we have, just loops over any cycle that we have. And we have here 2 for cycles, and also we have one more cycle here when we are calculating sum. So we can improve that. For example, I'm running lots of cycles, and then in this validation, I'm throwing away some of them. But there is more efficient way. Instead of running into a cycle and then disregarding it because it's not correct case, we might want not to run into it on the first place, which would be more efficient. And also, another area for improvement is we are calculating this get subarray sum. We are calculating it on demand. So if we run into some subarray combination and we want to calculate it, we are just on demand calculated here right in line. But this means that we are going to calculate we are going to run get subarray sum multiple times for the same inputs. And this can be optimized. So we can make sure that for each number of inputs, which basically means start index and length, we can calculate sum only once. And this is going to make some improvements. Unfortunately, it does not fit into this coding session, but you can try it. If you like this task, please try it. But for me, for today, that's it. So thank you for your attention.